Hello everyone, I am Udu Emmanuel. Today's topic is simultaneous inequalities. The question says, show graphically the region arrow which satisfies the set of the following inequalities. So we have about 4 inequalities here. 2x plus 2y less than or equal to 2, x plus 2y less than or equal to 16, x greater or equal to 0, and y greater or equal to 0. Question says we should show graphically the region which is represented by this letter R, which satisfies the set of the following inequalities. So what we are going to do here, we are going to first of all create a table of values for these linear equations here. Then after creating the table of values, we will now plot the graph. Then after plotting the graph, we will now shade each of the graphs and then locate the feasible region in the graph, which is represented by this letter R. So let's proceed. So first of all, I'm going to use the table of values for these linear equations. So to do that, I will first of all wipe this part of the board. So for the first equation, 2x plus 2y is equal to 2. I'll change it into a linear equation. Okay, since it's a straight line graph, I'll just need two values, a value for the x-axis and a value for the y-axis. So I'll take when x is equal to 0 and then when y is equal to 0. So when x is equal to 0, I'll substitute the value 0 into this equation here. So 2x plus 2y is equal to 2. When x is equal to 0, everything here will be 0. 2 times 0 is 0. So this becomes 2y is equal to 2. So to make x, or rather to make y, to get the value of y, I will divide both sides by 2. This becomes y is equal to 1. Or 2 we divide this 2, 2 divide this 2, and this becomes 1. So when the value of x is 0, the value of y is 1. When the value of y is 0, 2x plus 2y is equal to 2 is the same thing as 2x plus 2 multiplied by 0 is equal to 2. 2x plus 2 multiplied by 0 is 0. So this becomes 2x is equal to 2. Now to get the value of x, I'll divide both sides of the equation by 2. So this becomes 2x over 2 is equal to 2 over 2. And this becomes x is equal to 1. So when the value of y is equal to 0, the value of x is equal to 1. For the second equation, x plus 2y is equal to 16. I'll convert it as well into a linear equation. The value of x and y, I'm going to take two values again for x and y. The point where x is equal to 0 and the point where y is equal to 0. So when x is equal to 0, the value of that equation will become 0 plus 2y equals to 16. This is the same thing as 2y is equal to 16. Now, to get the value of y, I'll divide both sides of the equation by 2 to eliminate these 2. So this becomes 2y over 2 is equal to 16 over 2. 2 we cancel out 2. 2 into 16 is 8. 2 here 1, therefore the value of y is equal to 8. So when the value of x is 0, the value of y is 8. When the value of y is 0, the equation becomes x plus 2 multiplied by 0 equal to 16. Therefore, x is equal to 16 because 2 times 0 is 0. So at the point where y is equal to 0, x is equal to 16. So the other two equations or boundaries that we're going to plot on the graph is x equal to 0 and y equal to 0. So I'm going to draw my graph on the board. So these are the table of values for the inequality equations. So this is my Cartesian plane. I'm going to plot the equations on these graphs, on the graph rather, on the Cartesian plane. So the question says, show graphically the region R which satisfies all the inequalities. So I'm going to plot the graph, then I will locate the region R on the graph. So first of all, I'm going to plot the first equation. This is the table of value for the first equation. So at the point where x is equal to 0, y is 1. So when x is 0, y is 1. When x is 1, y is 0. So I'll draw a straight line to connect these 2 points. For the second table of value, when x is 0, y is 8, this is the point here. When x is 16, when x is 16, y is 0. That's this point here. I'll draw a straight line, another straight line to connect the 2 points. So this is a line that satisfies x plus 2y is lesser or equal to 16. And this is the point that satisfies x, 2x plus 2y is lesser or equal to 2. For x greater or equal to 0 and y greater or equal to 0. Now, whenever you see anything like this, these are non-negative values. Whenever you see equations like this and you are asked to plot the value of x or the value of y on your graph, let's say we can interpret this as x is equal to 0. So let's say you have something like this. Say maybe x is greater or equal to any value. Let's say x is greater or equal to 3, for example. You are asked to plot this on the graph. This is a vertical line. X greater or equal to 0 is this point here, 3. So the line of the graph is going to run through 3 like this. So it's a vertical line. So this point on the graph, x greater or equal to 0, is a vertical line. And it is the entire y-axis because it is at this point that x is equal to 0. When y is greater or equal to 0, the line of this graph also, this is a horizontal line. So if you have anything like this, say y is equal to 0, or y is equal to a value like 1, and you're asked to plot it on the graph is going to be a horizontal line. So if we plot that graph on the Cartesian plane here, this is point 1 on the y-axis. So this line is going to be a horizontal line like this, cutting through the point 1. So for this particular case, where x is greater or equal to 0 is this point here. So since it is horizontal, it is the entire x-axis. Okay? Now my lines are going to be thick lines because my inequality signs are not single. They have an equal to sign attached to them. So this is x plus 2y lesser or equal to 16. So it is not just lesser than, it is lesser or equal to. So whenever you see something like this, lesser or equal to or greater or equal to, the line, the graph of the line will be a thick line. The graph will be a thick line. Okay? So my lines are thick lines because the inequality sign is lesser or equal to here. On this particular equation, it is also lesser or equal to. On this equation, it is greater or equal to, greater or equal to. So my lines are thick lines. So the next thing I need to do, I need to shade the graph. Now to shade the graph, because the inequality sign here is lesser or equal to, it means that I will shade my graph to the left. So I'm going to shade this graph to the left of the Cartesian plane. For the second equation, the inequality sign is also lesser or equal to, so I'm also going to shade to the left. X greater or equal to 0, I will shade, x greater or equal to 0 is a vertical line, that is the entire y-axis. So I'm going to shade to the right because it is greater or equal to. Then for y greater or equal to 0, which is the entire x-axis, I'll shade in this direction because it is greater or equal to 0. So the point where my shading meets, I have 4 equations here, so to speak. So the point where all the shading intersect, that is the point that satisfies all the inequality. And that is the point arrow as a region arrow. And that is this triangle here. So this is the point where all the shading of my graph meets. When I shaded the entire y-axis, this place was shaded. When I shaded the entire x-axis, this place was also shaded. When I shaded 2x plus 2y less or equal to 2, this place was shaded. When I shaded x plus 2y less or equal to 16, this particular region was also shaded. So because all the shading meets in that particular region, that is the region that satisfies all the inequality. And that is the region arrow. So for questions like this and more, click on the link and join our class. In our classes, we break down difficult problems like this step by step. Join our online class today so that you can learn how to solve difficult problems like this. Click on the link and join the class now.